High Geometry, this is our review sheet. So let's take a look at number 1. It says that triangle HEF, that's the one on the left, is the image of triangle HGF, that's the one on the right, by a reflection. So I know that they're congruent. So now it says in A, triangle FGH, so FGH is congruent to triangle. So now I have to put them in corresponding order. So if it's a reflection, F goes to itself. So that would be F goes to F, G goes to E. So then G would be E would be next because G goes to E. And then H goes to itself. And so I would write H in. So I would not flip-flop F and H. Angle HFE. So let's go find that. HFE is my single red arc right here. And so that is congruent to angle F on the other side. So I'm going to write that as HFG. And then segment EH. So let's go. EH is this segment right here. So it's going to be congruent to GH on the other side. So make sure you put the G first and the H second so you have your corresponding parts in the correct order. So let's take a look at these 4 triangles, 4 sets of triangles, and see if we can figure out if they're congruent. So in the first one, hopefully you're marking that reflexive side and thinking side, side, side. No angles are marked anywhere. So in the next one, what am I supposed to mark? Well, I'm supposed to mark those vertical angles. When I do that, I can see that I have angle, the included side, angle. The tick mark is the side right in between them. So the next one, I have my reflexive side. Now be careful here. I want to point out, I'm going to draw it in blue and then I'm going to erase it. The angle we know about isn't nestled in between my 2 red tick marks. That's not what's marked. So it's not the included side, and now I'm undoing those. It's not the included angle that's marked in this diagram. It's another angle outside of my 2 sides. It's the non-included angle. So when I write my 2 sides, I can't write my angle in between them because it's not the included angle. This is an example of the method that doesn't work to prove triangles congruent. So I would write not congruent for the third one. And the fourth one, when I mark my congruent reflexive sides, I would see that this one is angle, side, angle. So then let's take a look at number 3. 3A, these are my isosceles triangle problems. I know that my base angles are the ones across from my congruent sides. So G and H should be equal to each other. And the 48 degrees is my vertex angle. So I'm going to subtract 48 from 180 to figure out how many degrees are left for G and H. And I get around 132. So since they're both congruent, since they're my base angles, I'm going to divide that in half. And then each one of them, G and H, are both 66 degrees. So for B, when I look at this one, I know that R and Q are my base angles. They're the ones that match. They're the ones that are equal to each other. So I know the 40 degrees is my vertex angle. I'd like to try to find angle Q. I need to find it so I know what 2x is equal to. So let's take 180 and subtract angle P, the vertex angle. That leaves me 140 degrees for R and Q. So that means since R and Q have to be equal, that means that R and Q are each 70 degrees. Well, if Q is 2x degrees, then 2x would be equal to 70, or in this case, x would be 35. X is not 35 degrees. It's just the number 35. It's my variable. The entire angle is 70 degrees. C is the number I had you change in class. The original problem I wanted to change, so I hope you scratched out what was on your paper and wrote the 78 in. So that was a change I had you do in class. So let's do this one. That's my vertex angle, and I know N and M are my base angles. I know they're congruent because they're the ones across from my congruent sides. So let's take my 180 minus 78. I find that I have 102 degrees left over for my base angles. Divide that by 2 and I get 51 degrees for both N and M. So let's move on down here to my two kite problems. So on the first one, it says that angle WXY, so go find that angle. Let me grab my highlighter. WXY is this angle over here. And it says that it's 94 degrees. So let's write that in. And I know if X is 94 degrees, then so is Z. And then it goes on to say, that's what I did. Then it goes on to say that ZWX is 112. So let's go find ZWX. It's the entire thing. The entire angle W is 112 degrees. But my angle W is split in half to create my two triangles. So I need to divide 102 degrees in half to find out what each side is. And so that's 56 degrees. 56 degrees and 56 degrees. And I believe this problem wants me to find ZYW. ZYW is this little angle right here. So my 180 minus my 94 for Z minus my 56 for W, and it looks like I would get 30 degrees for this little angle right here. So let's take a look at number 5. Angle WXY. Go to W, go to X, finish at Y. That is 133 degrees. So what do I know? I also know then that Z is 133 degrees. So then angle ZWX, let's go find that one, ZWX. Oh, it's this guy at the top. It is 60 degrees. The whole thing is 60, but it's being split in half. So I'm going to write in 30 and 30 on either side, since both those are going to be equal. And then this problem is asking me to find ZYW. It wants me to find this angle down here at the bottom. So 180 minus my 133 minus my 30 should give me 17 degrees. And I apologize. I think that's the exact same one that was in our book that we did last Thursday or Friday, depending on which class period you're in watching this. So probably meant to change those numbers a little bit there. So if it looked familiar, it should have. So let's take a look at this page. Number 6. Remember, the steps are all on page 10 of our packet for a proof. If you need a lot of support, don't forget you could watch the 10 and 11, pages 10 and 11 video. You could also watch the pages 12 through 15 video. That's a good 10 or so proofs that I go over. And if you want to print out those pages to redo them, you can do so. The blank packet is in our Unit 2 folder. So let's get started by first marking the given. So you can only mark what it says. E is the midpoint of AB. So if E is the midpoint of AB, by definition, it's going to split it into two congruent parts. Let's mark our tick mark and my tick mark. And I know somewhere in my proof, I'm going to say AE. Oh, it looks like it's right here. I'm going to say AE is congruent to EB, and that's going to be definition of a midpoint. So next, you guys, let's mark CD. E is the midpoint of CD. So now go find C and go find D. And if E is the midpoint, it splits it into two congruent parts. CE would be equal to DE. So now step 2, I have to mark what I should know. And in this diagram, I should know these vertical angles. So now I know I'm going to have in my proof those green angles somewhere, and my reason is going to be vertical angles are congruent. So now step 3, I look at my picture. Why are these two triangles congruent? Well, side, angle, side. And so now everything else in my diagram is congruent by CPCTC. So let's start filling this out. Well, the first line's always my given, and you'll see what's written there completely matches my given up above. Now the next one, definition of a midpoint, and then the next one has AE congruent to EB. Well, I know AE is marked in red and EB is marked in red, and that was the definition of a midpoint. I marked them congruent because E was the midpoint. I also did the same thing in blue. I did that to C and D. So this line must be for my other set of congruent sides. So I could write CE or EC, it doesn't matter. But when I write the other side, I guess I should write that as what, DE. So then that's my two blue congruent sides. Now I have a blank line. What else am I supposed to get in there? Well, this is a side. The red one is a side. Oh, you know what? I'm missing my angle. My green vertical angle's not anywhere. So this one is going to be my vertical angles are congruent. And when I write them, I can write it in any order as long as E is in the middle. I'm going to write it as AEC. So when I write the other side, I have to write it as BED. Now this next line has two triangles congruent. Remember, two triangles can be congruent only by our 5 ways. And in this problem, it was side, angle, side. Once that's true, all the rest of these two angles that aren't marked in red, blue, or green are now all congruent. So my AC is congruent to BD by CPCTC. AC and BD are corresponding parts. They're two corresponding sides of two congruent triangles. So let's take a look at number 7. Again, we've seen this diagram multiple times, but only mark what you're given. Step 1, RT bisects SRU. So that's this guy on the left. So I'm going to mark this angle and this angle. That's going to be in my proof. These green angles will be in my proof, and my reason will be definition of an angle bisector. Also, RT bisects STU. So STU is on this side, and if this is bisecting that, I also have these blue angles over here that must be equal because of definition of an angle bisector. Lastly, I have to mark what I know, and I know I have a reflexive side here. So now I look at my marked up diagram, and I realize these two triangles are congruent by angle, side, angle. So down here, I know my two triangles are going to be congruent by angle, side, angle. By the way, I also know that my sides, I'm going to have CP, CTC whenever you have sides or angles congruent after your congruent triangles. So let's get this all in my proof. The given, that I'm just going to copy down what it says. RT bisects SRU and STU. So my green angles and blue angles I have to add next. Let's see which ones they did for me. SRT is a green angle. So this line must be my green angles. That's definition of an angle bisector. So then the line up above is going to be where I write my blue angles. You can write them in any order the first time. T does have to be in the middle. I'm going to write STR, that's the one on top, congruent to UTR, that's the one on the bottom. And then I still need to get my red reflexive property in here. You can write them in either order. I'm going to write R first. When I write it on the other side, I will write them in the same order because this is a reflection, not a rotation. Let's take a look at 8 now. So number 8, I think this is the one that you guys had to change this. I had a misprint from when I typed it up. I believe you had to cross that out and write AB congruent to CD. So if you didn't do that and you had some trouble on this problem, then that was why. Those were something that you were supposed to fix in class. So let's take a look at this one. So let's go ahead and mark the given. AB parallel to CD, that's the top and bottom. Don't mark anything else parallel, just those two. Probably going to have alternate interior angles then because of that. AB congruent to CD, so I'm going to put a tick mark and tick mark. And now I mark the stuff I know. Well, I know my reflexive side. And I also know that if I'm given parallel lines, I make my Z, and this would be my Z with my two parallel lines in the transversal. And I know in the corner of my Z's, that's where my alternate interior angles are. So I know my two red ones are going to be alternate interior angles. So I stop and look at my diagram and figure out why they're congruent. I hope you can see that it's side, angle, side. It's side, included angle, and then a side. And now I'm ready to fill this in. My triangles, that's going to be side, angle, side. So the given, let's write that in. AB parallel to CD, and AB was congruent to CD. So alternate interior angles, those are my red angles. I'm going to write those in any order. I'm going to do BAC. And if I do that, then on the other side, I'm going to write DCA. Now the next line is completely blank. I have to think for myself what's missing from my proof. Well, you know what's missing? My blue reflexive side I haven't put anywhere. So it doesn't matter how you write it, but I'm going to write AC. Now it matters. On the other side, I have to write CA because this was a rotation. A went to C and C went to A. And that was my reflexive property. And now I can say anything else. Any of my other angles, any of my other sides are all congruent by CPCTC because my two triangles were congruent by side, angle, side. So let's jump up. Let's go back up. This diagram wasn't the best diagram. Sorry, I feel like now that I look at it closer, they wanted the 17x plus 9 to go with R. But for it to fit the theorem we proved in class we proved that opposite angles, of a parallelogram were congruent. So for our purposes, I believe what I told you in class is to let Q and S, let the 17x plus 9 go with the Q. Although I feel like it's supposed to go with the, well, I don't feel like it, I know it. But we didn't do the one where our consecutive angles were supplementary yet. So I'm just going to work on it as if it's opposite angles. And our opposite angles are congruent. So that means I'm going to set them equal to each other. If they're congruent, they're equal. And I do get a decimal. 35 equals 17x plus 9. I'm going to subtract 9 from both sides. When I do that, I get 26. So 17x equals 26. And when I divide by 17, this is where the decimal comes in. I believe you get 1.53. You could just say it's 1.5. I know most of our answers are nice, clean, pretty integer numbers, but we just happened to get a decimal for that one. So then number 10, again, one of the proofs that we did was that opposite angles were congruent. So I know that the 65 and the 5x plus 15 are opposite angles. They must be congruent. They must be equal. So let's set them equal to each other so we can solve for x. That's what our directions want us to do. 5x plus 15. And I'm going to subtract 15 from both sides. I get what? 50 equals 5x. Divide both sides by 5 and get what? 10 equals x. There's my nice pretty integer number. I hope this was helpful. Please bring any questions you have to office hours or back to class. Thank you.